Today's notes are almost identical to yesterday's notes, but today we're focusing on the cosine function. So I'm actually going to briefly skim through parts of this note sheet because it's so similar to what you learned yesterday with the sine function. I'm just going to point out the importance or the small changes between the two graphs. So to start off with, let's talk about moving around the coordinate plane. So when you're moving around the coordinate plane or moving around the unit circle on the coordinate plane, the graph of cosine is going to form the curve that looks like this. And while this curve looks very similar to the sine function, there is one major difference between the two of them, and that's because, or that is, that the cosine function starts at 1, and one full rotation goes from 1, hits a minimum, comes back up, and stops at its maximum or the value of 1 again. So that would be one full cycle for the cosine function. This is compared to the sine function that I'm going to sketch with a blue marker, so don't be confused by the two of them. Okay, so the sine function goes up, hits a maximum, comes down, hits a minimum, comes back up, and then repeats its process over and over. So this graph starts, as you can see, at 0, and one rotation goes like that. All right, so the sine function and the cosine function are slightly different in respect that they start at different points. Other than that, everything else about the two functions is the same. So graphing the cosine function, the cosine parent graph has a y-intercept of 1. There's your difference between the cosine and sine. The cosine parent graph oscillates, so that means it waves between -1 and 1. And the ordered pairs for this graph were derived from the unit circle. So looking at the parent graph, and I actually placed the unit circle in here so we can talk about where the values are coming from. Starting with 0. So if we start with 0 for our parent function, that means we're looking for when theta is equal to 0, what is the cosine value? So if I scroll up, when theta is 0, meaning 0 degrees, or 360 degrees, either way, it's the same point. But when theta is 0, what is the cosine value? And the cosine value at that point is 1. Next, we have when theta is equal to pi over 2. So this is asking us, at pi over 2, what is the cosine value? Here's pi over 2. The cosine value is 0. At pi, what is the cosine value? Well, on the unit circle, here's pi. The cosine value is at -1. At 3 pi over 2, the cosine value is at 0. And at 2 pi, which is also 0 or 360 degrees, so right back to the beginning, the cosine value is at 1. So here's how we know that the oscillating pattern or the wave pattern is going to repeat, because we started at 1 and we just hit 1 again. So if I graph this function, I know that I'm going up to a maximum value of 1 and down to a minimum value of -1. I know that I'm going to start at 0 on the x-axis, followed by the next term of pi over 2, and then pi, and then 3 pi over 2, and 2 pi. From here, this graph is going to start at 1. I'm going to graph this point. So at 0, I'm going to plot a point at 1. At pi over 2, I'm going to plot a point at 0. At pi, I plot my point at -1. 3 pi over 2 is at 0, and 2 pi is at 1. So this curve is a repeating pattern that looks similar to this. Make sure you indicate that the ends of your graph are turning, so I'm talking about these parts right here. Don't just draw that this graph goes straight up, because that is not true. So this is a wave pattern, like you saw at the top of this page. You need to make sure you always represent that wave pattern. And this is your final parent function. Same as the sine function, we have what we call the amplitude and the period. So the amplitude is found by the absolute value of A, and your A value is always in front of your function. The period is found by 2 pi over B, and the B value is always located directly before theta. So recall from yesterday's lesson that the amplitude is how high or how low the graph goes. And on this example right here, you can see the amplitude is the height. And the period is how long it takes the graph to repeat one full cycle. So if the graph starts here, it goes down, hits a minimum, comes back up to its starting point. That's the period. It's one full cycle. And then that cycle continues to repeat over and over and over. Okay, so I'll scroll down so you can see my answers to the on your own section, but please try to complete these by yourself. I'll just put my answers on the screen and pause for a moment before I move on to the next section. Next, we need to graph a cosine function. Today, we're just going to go over one of these. Once you go over one of them, they should all be very similar. So we need to start by finding our amplitude and period, and then we will graph the function. So the amplitude is always going to be the absolute value of your A term, which in this case is -2. And that simplifies to +2. Oops. Every time you have absolute value, your absolute value comes out to be a positive number. That's telling me that the graph is going to go up to 2 and down to -2. Also, one thing that we did learn yesterday was when you have a negative sign, so a negative leading coefficient, that represents that the graph is reflected across the x-axis. So instead of starting at +2, we're actually going to start at -2 on this function, but we'll talk about that when I actually start to plot the points as well. Next, we need to look at the period. The period is always determined by 2 pi over b. And here we have 2 pi over 1/2. When you are dividing by a fraction, it is the same thing as multiplying by the reciprocal. So this is the same thing as 2 pi times 2 over 1. And that tells us that our period is 4 pi. Also recall that the period goes between 0 and, in this case, 4 pi. But you do have to find those increments in between. So you have to find those other points to plot the values at. And you can find that by dividing the period by 4. So in this case, the period comes out to increments of pi, meaning we're going to go up from 0 to pi, then 2 pi, then 3 pi, and lastly 4 pi to complete one cycle. So again, we divide the period by 4. That tells us what each increment increases by. In this case, it was a full unit. Okay, so now we need to start to graph. So you can either substitute your value into the function. So for example, we could substitute pi into this function for theta. We could use our unit circle. We could solve for it. But we also know that all of the graphs follow the same pattern. And if we have a negative leading coefficient, cosine always starts at the y-intercept, meaning it starts at -2. Then it's going to go to pi, then to 2, back to 0, back down to -2. Make sure you indicate those tails or the curves on the end of this graph because it does repeat its pattern. And this is your final answer. And for the last example, we're going to use the given information to write an appropriate cosine function. So to write a cosine function based on what we know so far, we need to be able to fill in the equation of a times cosine of b theta. So we need our a value, our amplitude, and we need our b value, which is determined from the period. So the amplitude is how high and how low the graph goes. You can clearly see that the graph goes up to a unit of 1. So we're going to say that the amplitude is equal to 1. Means it goes 1 unit above the midline, 1 unit below the midline. Next, I need to see how high or how low this graph, Next, I need to see what one full cycle of this graph can do. So it starts at 1, goes down to its minimum, comes back up, it reaches its end point of one cycle. So this here, from 0 to 2 pi over 3, we're going to call this one cycle. That means the period is equal to 2 pi over 3. When we know what the period is, we set up an equation. We also know the period is determined by 2 pi over b. We know that we solved that and we ended up with 2 pi over 3. We know that from this right here. So without even solving this equation, if you have 2 pi in both numerators, you can quickly see that the denominator, b, is equal to 3. So that's my b value. So I have my a value, or my amplitude value, of 1, and I have my b value of 3. I also know my amplitude, my a value, is positive 1 because the graph starts at positive 1. If it started at negative 1, then my amplitude, or my a value, specifically my a value, would be negative 1. So to fill in the equation, I'm going to write out that the cosine function is going to be positive 1 times cosine of 3 times theta. And this is my function determined from the given information or determined from the graph. Again, I'll scroll down. You can check my answer for the on your own section, but you should be trying this by yourself. And the overall takeaway of this lesson is that everything between sine and cosine is very similar. The parent function points differ because sine always starts its oscillating curve, so it starts the curve at 0, whereas cosine starts the curve at 1. And those values are derived from the unit circle if you need to look back at that. But just remembering that sine is at 0, cosine is at 1 will be a very helpful tip when you're graphing both functions.